Howdy! Today we are looking at the Algebra 1 final exam review, and we're going to be looking through all the problems. We're going to begin with, I think, probably the first 5 in this video. So let's go ahead and look at some of these problems. Our first question is asking us to combine like terms. So we're not solving for anything, we're just combining our like terms. And we have 3x plus 7y minus 5x plus 4. And we need to determine which of those terms are alike. Now, for this type of problem, we need to look at the various types of terms we have. So we have an x term, that's our 3x. We have a y term, our 7x. We have a negative 5x, oh, that's another x term. And we have a 4. So we have 3 different types of terms in this one. We have x terms, y terms, and regular numbers. And the x terms go with the x terms, the y terms go with the y terms, and the regular numbers go with the regular numbers. Now, if we look at this, we only have 2 x terms which match. There's a single y term and a single regular number. So that means that our answer is going to have a 7y and a positive 4 in it. So that eliminates this as being one of our possible answers because it's missing the 7y and the positive 4. All 3 of the other answers have that, so we're actually going to have to combine our 3 and our negative 5 to see what we get. Well, combining like terms is, for the most part, using addition and subtraction, just like combining regular numbers. We need to do 3 minus 5, and that'll tell us how many x's we end up with. And 3 minus 5 is, of course, negative 2. But since what we were talking about was a 3x and a negative 5x, that means our answer is going to be negative 2x. So we need to find one of our answers which has the negative 2x in it, and that would be the 4th one. And as we discussed earlier, it also has our 7y, which was unable to combine with our x term, and our 4, which obviously cannot combine with our x or our y term. All right, so that was the first one. You got to look for things that have the same, either being a basic number or they have the same variable attached to them. And we'll see something else that we'll also have to look at later in the test. Another thing you'll have to consider when combining like terms, but we'll save that for another question. When we look at question 2 here, it asks us to solve for g given 2g minus 13 is equal to 3. And this is a pretty straightforward 2-step problem. So the first thing we need to do is we need to get our g term, our 2g, alone. And we need to do this by using our opposite operations. So since this negative 13 is attached to our g term using subtraction, we got to add it to both sides. Since negative 13 plus 13 is 0, we're just left with 2g is equal to 3 plus 13, meaning 16. Then we divide by 2, and we end up with g is equal to 8. So there's our solution, g equals 8. 2 quick steps and we're done. Now, moving on to question 3. Question 3 is just like question 2. It's just got a little bit more substance to it, meaning we have a few more steps we need to take. In particular, we have the problem of having p's on both sides of the equal sign and numbers on both sides of the equal sign. So we need to get all of the p's together and all of the numbers together on opposite sides of our equal sign before we can do the division like we did in this problem. So for my first step, I'm going to get all my p's together. And in order to move my positive 2p that's on the right side to the left side, I need to subtract it from both sides. 5p minus 2p is basically just 5 minus 2, which leaves us with 3p. We still have our minus 9, and we now have that it equals 12 because we moved our 2p over. Then, just like the last problem, we now need to add 9 to both sides. This allows us to get our 3p isolated on the left side and gives us that 12 plus 9 is equal to 21. So we have 3p equals 21. Finally, just like the previous problem, we divide both sides by 3, and that leaves us with p is equal to 7. So that is our next one. Again, just applying our opposite operations. We had to get all of our variables together that were on opposite sides of the equal sign, but once we did that, it was basically problem 2 all over again. All right, what about question 4? Well, question 4 is actually got some graphing involved in it and some solving too. So we need to solve an inequality and then graph our solution on the provided number line. We got a lot that we need to be able to see on this problem. So give me a moment while I adjust my desk to get all of this in one shot. There we go. So this is question 4. We need to solve the inequality j plus 9 minus 3 is less than 8. And the first thing we need to do actually is combine like terms like we did on the first problem, because you're going to notice we have a 9 and a negative 3 both sitting on the left side of our inequality. And thankfully, 9 minus 3 is just positive 6. So we have j plus 6 is less than 8. From here, solving for j is exactly like it would be if we had an equals sign. We just need to subtract 6 from both sides to get j alone, leaving us with j is less than 2. The only thing on an inequality you ever need to watch out for is when you multiply or divide by a negative number. Then you need to flip the direction that the inequality is pointing in. That didn't come up on this problem, though. So we just have j is less than 2. But now we need to graph it. And if we're looking at our number line here, you would need to choose one of these options down here on Big Ideas based upon what direction the arrow is going to go and whether or not our circle is going to be empty, like this one is, or filled in. The way you can tell whether or not our circle is empty or filled in is based upon this symbol right here. If there's a line underneath the symbol, it's filled in. If there is no line underneath our symbol, it means it is empty. And we place that empty circle above the number, which is given as being 2. The reason why the circle is not filled in is because it means that 2 is not a solution. And that is because 2 is not less than 2. 2 equals 2. If this had the symbol like this, j is less than or equal to 2, the circle would be filled in because 2 is less than or equal to 2, meaning that the closed circle is a solution and the empty circle is not. But we're not dealing with this example here. So all we need to do now is figure out what direction we're going in. And by that, I mean we need to figure out where the numbers are that are less than 2 because j is smaller than 2. And if we look at some of these numbers, we can just check some. Let's look at 6. Is 6 less than 2? You should immediately say no. If I have $6, I have more money than someone who has $2. Is 0 less than 2? Oh, 0 is less than 2 because if I have no money, somebody that has $2 has more than me. And that means that since this is a solution and this was not, our arrow points in the direction that our solution was. So we're going from 2 to the left. When you're actually doing this, you would select this option and then put the circle at 2 and it would automatically fill the arrow in. So that's problem 4. Now we're going to take a look at one last problem, number 5 here. And that'll be the end of our first video. So number 5 asks us to find the slope and y-intercept of the graph of the linear equation negative 2x plus y is equal to 4. Now, if you really wanted to, you could probably graph this thing and figure it out. But it's going to be a lot easier if we refer to one of our forms of linear equations. And that form is the y is equal to mx plus b, aka slope-intercept form. The intercept, of course, being our y-intercept. And this is quite handy because it allows us to figure out what our slope is, that's our m, and our y-intercept just by looking at a graph, just by looking at an equation, I mean, that is written as y equals something. So in order to get this equation to be y equals, I need to add 2x to both sides. So we have y is equal positive 2x and then plus 4. So our m, our slope, is 2, and our y-intercept is 4. Just be careful that you actually get them in the right order. And please do not put the slope as being 2x. The slope is only 2. It is not x. You'll lose a little bit of points. At least you'll lose a little bit if you end up putting 2x instead of 2. All right, so that's the first 5 problems on the practice final exam. Hopefully you found these explanations useful. We're going to go through a few more problems in our next one, including the rather daunting graphing a system of linear equations.